Hello everyone, welcome back to my channel. Today we are focusing on graph interpretations. All right, together. Let's start with a simple scenario whereby we have just one graph. Let's say we have a graph like this. Um, these are the two x-axis, not x-axis rather, but x-intercepts. We have -2 and 3, and then we have our turning point. Our turning point is at x is equal to 1. Our turning point is at x is equal to 1. Okay. Let's say we are asked to determine the values of x, to determine the values of x for which, let's say number 1, f of x is greater or equal to 0. Okay, please note guys, which this graph represent f of x. Are we together? Okay, f of x is the same as y. On your graph, the y values are the one that represents the graph. Are we together? So when y is negative, that means your graph is also negative. And when y is positive, simply means your graph is also positive. Are we together? So in this case, I know that below the x-axis, my y value is negative. So I will indicate the negative part of my graph with red. Are we together? Whenever my graph is below the x-axis, I know that it will be negative. Why? Because below the x-axis, all the y values are negative. But whenever my graph is above the x-axis, whenever the graph is above the x-axis, it's fine. Whenever my graph is above the x-axis, I know that my graph is positive. Together, and then there at the x-intercept, my graph is equal to 0. Right, together. So to answer this question, I'm asked for which values of x, or determine the values of x for which the graph of f of x is greater than 0, like this. Right, together. To answer this question, I will check where do I see my graph above the x-axis whenever x is between a -2 and 3. Together from here until there, my graph is above the graph. My graph is above the x-axis rather. Together, and then let's say the second question was saying determine the values of x for which f of x is less or equal to 0. Less or equal to 0, it simply means it's negative. I know that my graph will be negative whenever it is below the x-axis. When I move from a -2 like this, going to the left, I can see that my graph will be below the x-axis. When I move from a 3 going to the right, I know that my graph will be below the x-axis. So my answer will be whenever x is less than a -2, or whenever x is greater than, greater or equal to +3. Are you together? These ones are mostly simpler. And then sometimes we are asked something like this: for which values of x is f prime of x greater than 0. You don't have to think this thing is difficult, ne? Whenever they say this, they simply mean for which values of x is your graph increasing. There, this thing simply means above the x-axis. This one below the x-axis, okay? And then to answer the third one, where is our graph increasing? It's simple. We scan our graph moving from the left towards the right. Are you together? How so? Whenever I look from the left, is my graph going up or down? If my graph is going up, it simply means that my graph is increasing. Are you together? My graph will increase. My graph, the increasing and decreasing parts I will indicate with the positive, ne? My graph is increasing until it reaches a turning point. Turning point, my graph is no longer increasing. Are you together? The concavity of this graph changes now, and then it starts to decrease. Are you together? So I know that my graph is only increasing whenever x is less or equal to 1. They hardly put in, the equal sign there. Yeah. My graph is increasing whenever x is less than 1. Then number 4, where is my graph decreasing? Decreasing means less than 0. Where is my graph decreasing? My graph is decreasing whenever I move from 1 going to the right. I can see that the graph is moving downwards, so it is decreasing. So here I'll simply say whenever x is greater than 1. Are you together? And then maybe the catch comes whenever they combine the two things. Whenever they say f of x multiplied by f prime of x greater than 0. Are you together? Here guys, you just need to apply logic. You can see that you're multiplying two things. You're multiplying f of x and the derivative of f of x, and you are getting an answer which is positive. What does that thing mean? It simply means that you want to find a place whereby it's either my graph is above the x-axis and increasing at the same time, or my graph is below the x-axis and decreasing at the same time. Why is that? Because you are multiplying two things and your answer is positive. That means those two things you're multiplying have the same sign. Are you together? Where do I see the same sign on my graph? I'll indicate that in blue. Here and here. My two graphs have the same sign. Are you together? And then here as well. Both the graph and the derivative have the same sign. Does it make sense? So whenever I write my answer, I'll simply say this thing is true whenever x is between a -2 and 1, or whenever x is greater than 3. Are you together? And then maybe the other one would say for which values of x will the graph and the derivative have different signs. Why am I saying they have different signs? Different signs. Okay, why am I saying different signs? It's because I'm multiplying two things. I'm multiplying y and the derivative of y, and my answer is negative. I'll only get a negative answer whenever I'm multiplying things that have different signs, when the other one is positive and the other one is negative. Are we together? So I want the region whereby I have both my graph and my derivative having different signs. Are we together? If you can check here and here, both my graph and my derivative have different sign. The first part here, my graph is is negative because it's below the x-axis. However, it's also increasing at the same time. And then from here to here, my graph is positive because it's above the x-axis. However, it is decreasing at the same time. So that's why I'll just say this situation will happen when x is less than a negative 2, or when x is between 1 and 3. All right, together. These two questions, they can ask them in this manner. F of x divided by f prime of x greater than 0. The same answer will be this one, because you are dividing two things and you get an answer which is positive. It simply means those things have the same sign. Are we together? Other one, f of x divided by f prime of x less than 0. You'll get the same answer. Whenever you divide two things and then you get a negative answer, it simply means the things that you are dividing have different signs. One is negative and the other one is positive. Are you together? That's how you deal with a graph interpretation, guys. Ne? That's how you deal with graph interpretations. Sometimes you will have two sets of graphs. Sometimes we'll have two sets of graphs. Let's make another example before you do one of your own. What do you have here? At -1, 5 there. The x value turning point, say it's 3, and then also have a straight line that passes at x is equal to 3. I have a straight line graph there, ne? Let's say the point of intersection there happens when x is equal to 6. Okay, I have y, 0, x-axis. I must answer these questions. Let me write them here. Number 1, the values of x for which values of x, number 1 is f of x positive. Okay, this graph, the quadratic function represents f of x, ne? And then the other one it's g of x. Okay, for which values of x is f of x positive? Number 2, for which values of x is f of x negative? For which values of x is g of x positive? And then number 4, for which values of x is g of x negative? Fifth question. You can pause the video, guys, and do these questions on your own. Number 9. You can say f of x multiplied by f prime of x positive x multiplied by. Okay, let's answer these questions, guys. Okay, I will use different colors, ne? The red will indicate the y values, ne? And then the orange will represent the derivative whether is the graph increasing or not, ne? So with the red, I know that my graph is positive whenever it is above the x-axis, so I'll just write positive. Here it becomes 0 because y is 0 then, eh? And then it will be negative since it's below the x-axis 0, then it will be positive again. Are you together? And then for the straight line graph, I have positive there because it's above the x-axis, and now it will be negative when it's below the x-axis. Okay, the derivative simply tells us about the gradient, ne? This graph is forever increasing because it has a positive gradient. So it will be plus, 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 and plus. Are you together? However, for the curve, the curve will change concavity. So at first it is decreasing until it reaches the turning point. The turning point, I know that my derivative is 0, and then it will start increasing. Okay, to answer this question, for which values of x is the graph of f of x above the x-axis? F of x is the curve, the parabola. I know that this graph is above the x-axis whenever x is less than a -1 or when x is less than 5. Are you together? And then for which values of x is the graph of f of x less than 0? Less than 0 simply means the graph is below the x-axis. I know that my graph is below the x-axis whenever x is between -1 and 5. Are you together? Then now number 3, for which values of x is g of x greater than 0? G of x above the x-axis when x is greater than 3. When x is greater than 3, because I can see there my graph it's negative, 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 and then here it starts being positive because it's above the x-axis. Now together, and then for which values of x is the graph of g negative? The graph will be negative whenever it is below the x-axis. So when x is less than 3, the graph of g will be negative. For which values of x is the derivative of the graph of g positive? The derivative I did say with I've highlighted with orange. Né? The graph of g will forever be increasing because it has a positive gradient. So I'll just say when x is an element of real numbers. And then for which values of x is the graph of f increasing? The graph of f is increasing from the turning point moving to the right. Are you together? And we know that the x value at the turning point is 3. So I'll simply say the graph of f is increasing when x is greater than 3. Are you together? And now I want to find the values of x for which the gradient of g and y, the product zakhona zinikeza an answer which is greater than 0. Are you together? I'm multiplying two things and I get an answer which is positive. It simply means they have the same sign. Are you together? But here the trick is this one. The gradient of g is forever positive. So I will want I will want the regions where f is also positive. Are you together? So I know that whenever x is less than 1, here my graph of f of x is above the x-axis, hence it is positive, and the one of g it will be forever positive. Are you together? So when x is less than 1, from 1 going to the left, another one from 5 going to the right. Are you together? So this thing is true whenever x is greater than a negative 1 or whenever x is greater than 5. And then number 8, for which values of x is f and the gradient of x has a negative product? My gradient is forever positive, so I need to find a space whereby y will be negative, because when I multiply two things and the answer is 0, simply means the other one is positive and the other one is negative. Are you together? So that thing will only happen whenever x is between -1 and 5. Why am I saying that? Because I know that my curve from -1 to 5, it's negative. Are you together? And then number 9, I'm asked to find that for which values of x is the graph of f and its derivative positive. Okay, they must have the same sign. I'm focusing only on the curve where they have the same sign. When I look from here to here, both the red and the orange are negative. Simply means the graph is below the x-axis. That means it's negative, and the graph was still decreasing at that time. So when x is between -1 and 0, I have I have my graph and the derivative having the same sign. Are you together? Another place is when x is greater than 5. Why? I'm just focusing on the curve only. Ne? Why is that? Because I know that my graph is above the x-axis and my graph is increasing as well. Are you together? So whenever I write here, I'll simply say whenever x is between a -1 and 0, or when x is greater than 5. For which values of x is x multiplied by y positive? That means both x and y must have the same sign. Are we together? And that thing will only happen when my graph is at the first quadrant and at the and at the third quadrant. Are we together? Why first quadrant? First quadrant, I know both x and y are positive. On the third quadrant, I know that both x and y are negative. Are we together? So I'm only focusing on the curve. Oh wow, did I write 0 there? Oh, I made a mistake here, guys. The x value turning point is 3. I should have wrote 3 there, as kissing, because I did indicate from 1 to here. The x value here is 3, ne? Okay, now I'm focusing on the last one, ne? X and y, their product will give me a positive answer. That means both x and y are positive, or both x and y are negative. I know that both x and y will be positive when x is greater than 5, because I'm focusing on the curve, ne? When x is greater than 5, both x and y are positive, or they are both negative in this smaller space here. They are both negative. So I'll say when x is between -1 and 0. These things, guys, they just want you to apply the logic, ne? Just know that whenever they talk about f prime, they are telling you about the gradient of a tangent to a curve. But you don't have to think hard about it. You need to check whenever you move from left to right, is your graph going up or down? If your graph is going up, simply means your graph is increasing. If it's going down, it simply means your graph is decreasing. Are you together? And then y is positive whenever your graph is above the x-axis, and y is negative whenever your graph is below the x-axis. It's as simple as that, guys. No? Please apply these. Comment, like, share. Don't forget to subscribe too. Yeah. Thank you, guys.